Hello, folks. Please welcome Saransh. Saransh is a senior security engineer at Grid. Saransh is going to present something which is very hot, the MCP server, where you can have a conversation with the AWS environments and all. So today we'll explore AWS security with him while conversing with the AI. With that, can we get a big round of applause for Saransh? Welcome. It's all yours. We just do a mic check. I think you're fine.
Yeah. Okay.
That's it.
Good.
Good.
Okay. So guys, everyone has settled down. Yeah. Okay. So I would request people to just scan the QR code. That is specifically for the Zoom meeting, so that you can actually connect and follow along in the Zoom call. Okay. Guys are done. Okay. Cool. All right. So without a further ado, let's just quickly jump in. Okay. So good afternoon, everyone. Thank you for joining my workshop on conversational security engineering on your AWS environment. If everyone has settled down, let's just quickly start and let's just quickly jump in. So before we begin, I would request people to scan the given QR code. This is for following on the presentation. The entire workshop is very, very interactive. The different type of tasks and the prompts that we are going to solve. Every single thing that is like the task, prompts, videos, solutions, everything is actually within the slide. So you would have to actually interact even for the sign up for the labs as well. So if everyone has done that, and even if you want to follow along for the moment, you can scan later on and actually connect with the presentation later. So hey guys, my name is Saransh Rana. I'm currently working as a staff security engineer at Cred. I'm currently leading the cloud security team at my organization. I am also a AWS community builder in in security. Other than that, I have also done a lot of open source contributions as well, where I've developed IMDS Shift and Dial as well. IMDS Shift is majorly around moving and migrating your computes to IMDS v2 seamlessly. And at the same time, Dial is more around security misconfigurations detection via event bridges and AWS Lambda. So before we begin, I would like to ask people who all know what Cred does, the company that I currently work with. Okay, that's a fairly low number, but that's all right. So people who are actually unfamiliar with the platform and the company, we are a trusted payment platform in India. We actually target the top 25 million credit-worthy plus customers in our current country, which is specifically the customers within India. We have more than 13 plus million active users, where we try to target and try to actually maintain the creditworthiness between all the customers that we own. And we majorly process over $80 billion plus of total payment values that we actually handle across a platform, right? That includes your credit card bills, UPI payments, bills, everything that you actually have in our Indian ecosystem. And when I actually say that there are $80 billion worth of total payment value, we actually become the prime target for a lot of adversaries out there, right? And at this scale, the security becomes very, very paramount and even existential for us to actually manage, right? And that is where I'm actually coming from. And most of the problem statements that I've actually tried solving and tried actually, working around are the ones that I actually tried, that actually gave this tool a birth, right? So we'll just quickly talk about the agenda. We'll talk about why conversational security engineering. Post that, we'll introduce the MCP server that we developed. Post that, why exactly do we need this MCP server? Post that, we'll discuss how does it work? How does cross-account work? How does it have the organizational visibility? We'll showcase a small demo as well, where we'll perform a UEBA, which is user behavior analytics of a specific username using the MCP server. And post that, we'll deep dive into the lab. And post that, we'll kind of do like a verification of results and key events. All right. So before I begin, I would like to ask people, and I like to share different type of problem statements that I keep getting from my CISO, my manager, and different kind of things, right? The first and the foremost is actually where the most common question that I keep getting is, can you share all the resources owned by a specific team within my AWS infrastructure, right? Something, for example, in our QA team, right? So what we try to do is we try to figure out 20 plus CLI commands, navigate through multiple AWS accounts and multiple browsers that we have. And then a lot of failed attempts are actually there between, like the Python script that you write or like the bash script that you write. actually to automate the discovery of those particular inventory, right? And even after all those things, most of the time the results are actually invalid. Most of the times the result is actually 70% or not even 100%, right? Which does not actually give us the complete visibility. Similarly, another statement that I keep getting from my managers is that what is the attack surface of a payment service, right? As I said, that the entire company's backbone business is around payment card industry, PCI DSS, PPI data. So this is the most common question that I keep getting from my managers, that what is the attack surface of a specific microservice, right? So what we try to do is we try to connect with the right service owner, right? And most of the time when we connect with those service owners and try understanding the architecture of a microservice, what usually ends up happening is the devs usually respond back with, I joined 6 months back and I don't know the architecture at all, right? And which actually gives us that particular gap again in the visibility of understanding what is actually owned and what is the complete visibility of my AWS infrastructure, right? And similarly, if you kind of go ahead and connect with the SRE or DevOps engineers at the same time, most of the time, they also kind of respond back with, let's say, you're trying to figure out a port 3389 open on a specific service. You try to understand why is it open, right? And what does the SRE and DevOps engineers respond back with? The service owners can share more details about this particular use case, right? And then we are again running behind people and trying to figure out what is the actual entire infrastructure for a specific microservice, right? Similarly, a very interesting use case and something that I've actually personally experienced, a DNS over HTTPS activity detected from a specific IP address, right? And this is just an example. This is a GuardDuty alert that I received fairly recently. But again, right, I mean, if you're at 2 a.m. sleeping and you get this kind of an alert, DNS over HTTPS is fairly, very tricky situation that is happening in your AWS environment. Most of the microservices will never actually work utilizing DNS over HTTPS unless explicitly required. And as I know that my services will not actually utilize it, why is it happening? So what ends up happening? The detection teams, they end up running 50 plus CLI commands. They end up opening 25 plus browser tab sessions. And then to find that specific IP address that is actually invoking this, it takes more than 2 hours to actually hunt what is actually happening. Why is this particular activity being generated at any given period of time, right? And then your complex queries and then constant fiddling between LLM, GPT, Claude, and your Athena queries or ELK queries that you run to actually detect a specific event or any kind of things. You actually just just keep on fiddling between the LLM and those things, right? Maybe extended this one. Once again, you can share. Perfect. Thank you. All right, sorry about that. Yeah, and coming back to DNS over HTTPS, what ends up happening, we kind of try figuring out what is the exact query that we want to run. Maybe it might be an Athena query, it might be an ELK query, Elastic query. And most of the time, those LLMs and that the log source that you have, they don't have that exact connect, right? The table schema, how the data is actually partitioned, what are the columns that are actually partitioned. That particular visibility is again not there exactly, right? Which actually ends up not helping us out, but maybe we might be able to figure it out. But most of the cases, it actually takes a lot of time to find that particular result, you have to kind of, run between GPT and all those things, right? And similarly, the last thing, if card tokenization service, microservice is compromised, what can attacker access, right? Similarly, in the similar case, what we end up doing is we try to actually run multiple CLI commands, navigate through multiple browser sessions, and try to map out the entire infrastructure of a microservice to understand what can actually go wrong, right? There are automations, but then we'll have to deep dive into the IAM permissions and understand what is the exact blast radius of this microservice at any given period of time, right? And essentially, what we end up doing is we try to create assumptions, but actually that is not exactly the reality. We try to fiddle around between the assumptions and try to validate those assumptions at the end, right? Which actually is not really valid. So the bottom line here is, instead of running 50 plus CLI commands and navigating among logs, we should be able to just ask which AWS account does this access key belong to? Show me attack paths from this public EC2 instance. What is the blast radius if this IAM role is compromised? Or generate a threat modeling report for a payment microservice. So essentially, we need conversations, not command lines, right? And I would strongly advocate that people who are starting their career in cybersecurity, information security, they should learn how command line works because they will actually learn how the vertical of that particular thing actually works. But people who are actually spend more than 7 years, 8 years, 10 years, they don't really want to fiddle around command lines, right? They want results quickly. When my CISO is actually asking for a report, I would need to do my work very quickly and share that report, right? That is where this statement is coming from. So with that being said, meet AWS Security MCP server. It's a security MCP server for AWS security operations. You can perform unified cross-account security operations with it. It will help you find needle in a haystack. You can correlate multiple log sources at any given period of time into one single place. You can perform LLM-powered threat hunting utilizing this. And at the same time, you can generate reports, whatever reports that you want to generate with this, right? And the best part is it's extensible to AI agents, which we'll see later in the workshop. So why exactly AWS Security MCP server? So the first and the foremost is it's a read-only access. The entire MCP server works only on security audit IAM policy. Essentially, it does not give you access to perform any create, update, or delete operations, which essentially for security engineers, which matters more to actually read and understand the metadata of a specific resource, which actually is very, very helpful. It has a very smart filtering system, which helps you to maintain the token size, the content length of the MCP client that you're using, and also helps you to only target the security related metadata that you want to find, right? So essentially, for example, let's say you're trying to find an IAM role, which can be assumed by an external AWS account, right? These kind of tools, these kind of particular problem statements can be utilized via this smart filtering. Third is it's a single server. It's a single server. Essentially, it has access to around 20 plus AWS services, which spans from the major services like EC2, S3, IAM, GuardDuty, SecurityHub, etc. And obviously, it's a very, very less management when you're dealing with one single server. It has organization visibility. Essentially, when you're running this MCP server, it can utilize the cross-account access and gain access to all the accounts that you have within your AWS organization. And it's specifically built for security engineers to perform all the read operations and even understand what is actually going wrong and connect those dots between different resources that you actually find, right? All right. So with that being said, let's just quickly understand how does it work. So the first and the foremost, we'll just begin with the timeline process. The first and the foremost, let's say you deployed this MCP server on your environment and you add a statement saying that I want to see what are the running EC2 instances in my AWS account right now, right? So the first step is actually when you write the query. The second step is actually when this query is interpreted by the MCP client, in our case, Claude Desktop or Cursor Pro or anything like that. In this case, the client reasons, it understands what exactly needs to be performed. It selects the specific tool that it needs to be performed. In our case, it is performing EC2 security operations. And specifically, it is trying to target an operation named as list instances, if you can see here, right? This is a particular tool that is actually invoking. Post that, it is actually adding a parameter and a session context, which we'll discuss later. So once this particular client reasons and the request has been generated from the MCP client, this request reaches the MCP server now. Now the entire MCP server is broken down into 3 different layers, which we see right now is the service layer, the first layer. The service layer essentially is the responsible one that actually deals and understands which AWS service are we trying to contact. Is it EC2? Is it S3 or is it IAM? The second thing that it checks is what is the operation that we're trying to perform. In this case, if you see, the operation is list instances. In this case, the operation would be list instances, and that is how it's actually understanding that we need to invoke this. The third thing that it actually figures out, what are the parameters required for this particular operation to be completed. In this case, if you see the parameters here running, that is the parameters required for invoking this particular operation, that is list instances. And the last is on which particular AWS account are we doing this, right? And that is where the session context comes into the picture, right? Once the service layer actually got all this kind of results and figured out, okay, these are the set of things that we need to perform. Suppose that this entire request is sent to the registry layer. Now understand this registry layer more or less like a central hub where you're deploying smaller tools or raw tools that you want to invoke. In our case, the list instances that we are trying to invoke as an operation is actually registered on this registry layer. Now this registry layer acts like something like an availability kind of a thing. Something like, let's say you've developed a new tool that is solving a specific IAM use case. You can actually go ahead and just deploy it on registry layer, and the registry layer will take care of entire, entire exposure to the MCP client by itself, right? It checks for if the tool is actually valid. It checks if the tool is actually present within our registry or not. And then it also maintains whether or not this tool is actually working or not. Once this entire request and the response has been received at registry layer, the entire request is sent to the tool layer, which is the raw tool layer that we currently own. That is the tool layer which actually is responsible for making those AWS SDK API calls. It does formatting of those responses. So when we're getting responses back, we get like a huge JSON value, right? Let's say you have 5,000 EC2 instances, but at the same time, 5,000 EC2 instance might invoke and eat up all your token and the content size that you have on MCP clients, right? So the tool layer essentially performs second order formatting for specifically targeting the security related metadata that you want to see. In our case, let's say I'm trying to list down the running EC2 instances. In our case, it will go and check if it has an IAM instance profile, what are the security groups attached to it, what is the instance ID, when was it created, what is the SSH key pair. These are the kind of data that we're kind of breaking down and doing second order filtering on top of it, right? So essentially, if I kind of go ahead and see it on how it looks like at architecture level. So starting from the top, so that was the first step when we actually added as a query, when we asked it to actually say that what are our running EC2 instances. So the request came to the second layer, which is the service lab layer, which essentially is responsible for nesting multiple multiple operations across your AWS environment. So if you see, there's EC2 security operation, there's IAM security operation, and GuardDuty operation. Similarly, like there are around 34 more services like that, which are basically exposing as a specific service to the MCP server, MCP client. In our case, the EC2 security operation was invoked, and then the entire request was forwarded to the tool registry layer. And then it is actually responsible for managing and routing the entire request coming from the client to the server itself. Now, once you see the tool has reached to the raw AWS tool layers, this is the place where we are actually building those smaller tool sets that we want to perform security operations using them, right? In our case, for example, let's say you specifically want to find public S3 buckets, right? If you kind of write a Python script, it might take like probably 75 lines or maybe less than that, right? But in this case, there are tools specifically built for that. If you want to find an IAM role that can be assumed by a specific principal, these are the kind of tools that are actually developed and designed across this layer. So that is how the entire process kind of actually works. Once the request has received to the EC2 tools layer, the AWS API and SDK tool layer actually makes those SDK calls and then perform all those operations as we discussed just now. Okay, so if the architecture is pretty clear, let's understand how does cross account actually works in this entire MCP server, right? So the first and the foremost, when you actually run the MCP server understand what kind of credentials are you actually using, right? So it might be possible that you're using credentials on your environment variables. It might be possible that you're using you're running this MCP server on an EC2 instance metadata service, or let's say an ECS service, which is essentially responsible utilizing task metadata service, which again is a credential handling, which is completely different, right? So it tries to understand the kind of credentials that we're dealing with. Once it has actually verified that, okay, the credentials are valid, everything is working perfectly fine. The next step that it does before the MCP server starts, it actually does like a list organization support, which basically understands whether or not the given credential has access to AWS organizations or not, which helps me list down all the available AWS accounts that are currently present in my AWS organization, right? Once we have the list of accounts, what we try to do, we try to specifically assume a role on all these accounts. So essentially, we basically say that this is the IAM role that you need to assume. Once all the list is present with us, we try assuming role on each single account parallelly so that we can generate valid credentials across it. Now, once the role assumption has been completed, the last part, which is the most important part, and wanted to keep it in a way where we don't expose STS credentials back to the MCP client, because as we saw what happened with GitHub MCP server, it ended up exposing private information related to the repository itself, right? So the entire session object map and that's what we are trying to call it, the session object map. Once it has assumed that role, usually the Boto3, the way that it works, the SDK it works, it has a specific operation named as session, right? Boto3.session, if you guys have worked around with it, right? So what does it do? It actually takes those credentials, assumes the role, creates a valid session object, and just creates like a hash map across it, right? So let's say you have 5 AWS accounts, prod, stage, dev, all those kind of things. So it will actually create a session context. If you can see the account ID underscore the account name, essentially. So whenever you want to invoke any specific API call specific to, let's say, a prod account or a dev account, essentially the MCP client would be responsible for maintaining the session context, right? Invoking this entire MCP server using the session context. So essentially, what we have done, we have taken the entire credentials away from the end user, because it might end up also be like a treasure hunt for a lot of attackers as well. So the entire entire credentials are never exposed to the user. The only thing that is exposed is actually the session context, which you can utilize by simply saying that, can I actually check the stage account or something like that? And the LLM is so smart that it will reason and understand that this is the session context that we need, right? And once the entire session object map has been created, the valid sessions are actually present with us. The MCP server finally starts, and then it starts for incoming client connections, right? So if you see in the bottom, this is exactly the way that a specific MCP client, let's say Claude in our desktop, actually invokes this MCP server. So the first operation is list instance. That is the one that we are actually invoking via the raw tool layer. Post is the parameter we want to specifically look out for the running instances. And then this is the session context, right? We are trying to target our production environment, which is essentially targeting the production account and trying to access the prod, dev, and stage account at any given period of time. So yeah, I mean, that is how the cross account works in this MCP server. And if everyone is following along, let's just quickly see a small demo. The demo is basically around, let's say you're working in a detection team, you get a very, very strange response that there's IAM session role that is generating valid API calls, even access denied calls. And it's like a small P0 ticket for us. So we are performing a UEBA, which is user behavior analytics also of a specific IAM user. And we are trying to understand how we can utilize this MCP server utilizing this, right? All right. Okay. So if you can see, we have added a lot of strict rules. We have added a task saying that, can you perform UEBA for a username user test for the specific date 25th July across my AWS account? I've given the Athena config. I've added multiple sample query as well, so that LLM is able to actually understand what kind of queries do I need to run. It's better that we give it the best information that is available out there, because if we keep on fiddling between the table schema, the table metadata, it might actually end up missing out on a lot of token sizes. So if you can see, it has already starting the strategizing of the UEBA investigation that we're doing, and it's performing a UEBA on 25th July. The first and the foremost thing that it did was checking what is the connected accounts that we have. In our case, there are 3 AWS accounts that are connected currently. And it has also figured out there's a CV security account, which is actually a valid session as well. So if you can see, we are invoking we're trying to understand the table schema of our CloudTrail database, and trying to understand and try to write the right queries specifically using LLM. So it's utilizing sequential thinking. It's better to utilize this. Even without sequential thinking, you can utilize it, but I would actually prefer using it because it helps you to perform all the sequential tasks that you want to do. You can help to actually strategize your plans as well. So now that it has actually completed the sequential thinking, all right. So now it's actually running a sample validation query. So on Athena, specific Athena security operations that we have as a tool on MCP server, You cannot perform any delete operations. You cannot perform select star from star. You cannot perform any describe star kind of operations, because we specifically want to keep this entire Athena into only querying that particular log source that you want to delete. So yeah, I mean, the entire Athena would actually run on limit queries only. So that is the way that we have actually, like tied it down to, running a certain set of queries the way that we want. So it has actually figured out that, okay, the validation query actually worked with a limit of 5. The query was working, the table schema was perfect. And now the query, the LLM is actually running that entire Athena query that is basically of limit of 500, essentially getting the entire results from the particular CloudTrail database. Okay. Yeah. So if you can see, this is a report that has been generated. You can see it has a mixed behavioral patterns, notable finding like extensive cross-account access attempts, multiple authentication failures, around 62 authentication events, multiple assume role calls. And the best part, it also understood that the user was utilizing an SSO role and then moved to a task role, which is a very unique and a very interesting thing, right? The LLM was able to understand those kind of data utilizing CloudTrail database itself. The IP addresses that were utilized, the temporal analysis, right? I mean, different phases of the attack that happened. And you can see like initial activity burst, multiple access denied errors, multiple console attempts, and then primary operation period, like SAML authentication and all those things, right? So as you can see, like even it figured out that the user agent that actually was utilized for that particular operations, all are different. And then you can see different things that the attacker was actually performing, right? Yeah, you can see like within seconds, it attempted to access multiple organization accounts and all those things, right? And yeah, I guess that is the way that we actually perform UEBA. So now, post this, what we actually went as a detection team, we reached out to the security team, said that what is happening? Why is this IAM role doing this? The detection team, the security team responded back with that we have deployed this tool and we are trying to understand whether or not this tool is actually legitimate. The operations performed by this tool is actually legitimate or not. So if you can see, whatever log sources that it actually queried, it's actually going to the GitHub repository now and trying to understand whether or not this tool actually is performing legitimate actions or not. And in most of the cases, actually, right? I mean, there are different teams across engineering teams, and most of them keep on deploying a lot of tools, right? Most of them actually have, like, detection teams have a little bit of a hard time when people are not actually notified that this tool has been deployed within our infrastructure, right? In these cases, this MCP server actually helps pretty well. So as you can see, it's an expected tool behavior. It was able to understand that this is a legitimate activity, but it also figured out that there are few suspicious activities, right? For this example use case, I've utilized a similar this particular tool itself so that I can showcase how it can perform. So you can see it tried doing web console attempts. The MCP tool should operate programmatically, not through console, right? And that's very unique. I mean, most of the cases when we are trying to actually formulate this hypothesis and formulate a valid response from it, it might take a lot of time for us to actually validate this entire hypothesis that we have. But within seconds, it was able to understand this. It was able to understand there were different session names as well, with different names. Yeah. And yeah, and it also says that the tried accessing different accounts and all those things, right? So this is a brief demo of the tool. This is what you'll be dealing with today. And I hope you guys have fun. Before we start, I'll just try to showcase a deployment strategy as well. If you want to deploy it across your AWS infrastructure, how you can do it. This is the best way that I figured it out myself. So if you can see the MCP client that we are dealing with, essentially Claude desktop or something, we can deploy this MCP server on our private hosted zones on our Route 53. Let's say you are dealing with, let's say you have a domain that is actually running on a private hosted zone. You can deploy it on your private hosted zone, configure an internal load balancer, and create this MCP server as an AWS ECS service. You can actually do it across your EKS pods as well. But for this use case, I was trying to utilize ECS service. Once we have a single task running, long-living task that we are running, suppose that we have an IAM role that it can assume across the organization. And that is how the entire deployment strategy can be utilized for this MCP server. So if you guys are done, all right. Yeah, so, all right. So let's deep dive into the lab. So today we are going to deep dive into a day in the life of a security on-call engineer. We will utilize our MCP server and see how it can quickly aid you to identify different type of issues, misconfigurations, even like connect dots across your AWS infrastructure. So in the task, you guys are going to be serious black. We have utilized Harry Potter's terminologies so that it's easier to understand. All right. So the workshop agenda is the first is the prerequisites, getting the lab access. There's a QR code, there's a Google form you need to fill up, you need to add your email IDs and all so that I can actually create your SSO users. There's also a video where you can utilize the video to actually, like actually register with the lab and how you can configure it manually. The second section would be the warm-up section where we'll solve a unique bug bounty problem statement with product security team. The product security team has actually tagged us on a specific security ticket. And then we'll try to understand what are the critical vulnerabilities across our infrastructure. Post that, the second section is stretching our muscles, where we will begin working with detection team. We'll be also working on aiding them across this entire detection and the ongoing incident. Post that, we'll begin with the flexing the code. That is the last section of for us, where the detection team has granted us access to the labs, the logs, and the log analysis and everything can be done within this. And post that, we'll do like a report correlation. All right. So before we begin, guys, these are the required tools and dependency for the given lab. You would require Python 3.11 or Python 3.9 also kind of works. Need UV, MCP proxy, you require Claude desktop cursor, and specifically you would require Chrome, Ultra, or Max plans because the MCP server is essentially a little heavy in terms of the tools that we have currently. So that's completely fine because the kind of operations that the MCP server is able to perform, it's completely valid to utilize a higher token limit. And yeah, I guess you can actually utilize the given QR code and actually add your email IDs and all. I'll create the user IDs, just post that. Yeah. You guys are done. Okay, please go ahead. I'll just quickly create the. I'm just going to remove the presentation for a while. I'll just quickly create the IAM users. Yeah. Yeah. So false positives, there were false positives for sure. Sometimes when the LLM starts hallucinating, and that majorly is the reason behind it is because the chat window that you're actually dealing with actually just gets too big. That's the time when it starts hallucinating, right? But when it actually deals with the logs like CloudTrail logs, VPC flow logs, so luckily all the LLMs are kind of trained well with the AWS docs. So like it understands the log passing and everything very pretty well. So when it starts reasoning and kind of creating that hypothesis, in those cases, most of the time, the hypothesis is not exactly 100%, but somewhere around 95%. But that gives you a very good standpoint to begin your investigation from. But when it comes to specific false positives in cases of, let's say, an S3 bucket being not public, but yet actually marked as public, in these cases, then there's no hallucinations like that. It gives you like the 100% result. Yeah.
Do you have some sort of testing plan that you have to ensure that assumptions that it does it's reasoning?
Yeah.
So, because what's doing is linear, it's a smart law.
Yeah.
Open the exercise. So according to this was the entry of the presentation based off of these particular for these account, cross-functional accounts. things
Yeah.
like that. Is that something you've tried out?
Mm.
Is that an exercise?
Okay, so if I understood your question correctly, is it you're trying to ask that whether or not did I?
If there's some testing involved.
Yeah, yeah. So most of the time, yes, because I've tried utilizing this entire MCP server on an ongoing incident in my organization. Most of the time, it actually works pretty well. Given that the scale of the organization that I work with, like it is actually able to deal with multiple thousands of accounts. So that's pretty cool. So the best part is actually if you try to say that you go ahead and just try to, scan entire 5,000 accounts. In those cases, most of the time things might actually fail. But if you try to say that, okay, can you, scope it down to specific accounts, let's say 15 accounts, in that case, then it's pretty solid. All right, if you guys have registered for the labs, okay, can I go ahead if you guys have done? Okay, cool. All right. So this is a brief demo, guys. This is the way you can actually configure the entire lab. When I say the lab, you're actually configure your AWS SSO profile and you're running the MCP server locally. Okay. Should I zoom in a bit? Able to? Yes, not. All right. So the first thing is pretty straightforward, configuring your SSO profile. You're just adding the URL specifically for this particular SSO URL. You have to log into the SSO. The username and the password that you created would actually prompt you to add your profile credentials and all. Yep. And once your username and the password has been added, you can actually just configure the entire SSO like that. Post that, we are trying to utilize a profile which we have created using the configure profile. The second is the role ARN. This is the role that you would be assuming into the lab and trying to access the AWS account using this lab. And then we are creating a role session name so that we can specifically see people who are trying to use.
Yeah. So you want us to run this locally?
Yeah, you can run it locally.
Okay.
Yeah.
AWS.
No, you don't.
What you set up was just the account for us to scan?
Yeah.
Okay, not
Yeah.
actually like ECS.
Nothing like that. Nothing like that. You can just utilize the given ways.
Okay, so we need to go to like the GitHub and follow like all.
Yeah. I mean, all the set just instructions are there. But yeah. So we have actually exported the variables now. And now what we are trying to do is trying to utilize the SSO profile. And then we are basically doing an assume role call to that particular IAM role that we are assuming for MCP server. And then it exports the environment credentials to the local profile. So now that we have the entire AWS credentials, SDS credentials, we are basically cloning the repo. And then once the repo has been cloned, we're just creating a PyEnv file and all those things. Post this, once the repo has been cloned and we have created a virtual environment for Python, we have to edit our config.yaml file. The reason is because we are going to run Athena queries. The official way that we run Athena queries is via specifically targeting a query bucket and a results bucket. So we have to edit the default location here. So on the slides, we have actually added all the things that you have to add here. So we just quickly add. Yeah, so this is a config file for the MCP server before you run. Yeah, that's all. Yeah. And once this is done, so once the config file has been set, you can start running your MCP server. This is fairly straightforward. All right. So you just have to do like a tool installation of MCP proxy, which is utilizing SSE. And then we are installing the required packages. And then we are running the MCP server using the given command. You will have all the instructions within the presentation itself. So yeah. So if you can see the MCP server is started, you can see that it has discovered 5 active AWS accounts and it is processing 4 targets accounts. And one of those ones has actually gotten an access denied because it's a management account. So yeah, it has access to 4 AWS accounts now as a cross account. And the MCP server is running perfectly fine now. And once we have set up the entire MCP server, we are configuring our Claude desktop file where we are adding the absolute part to the MCP proxy. You can utilize the given command. and take this absolute path and just add it on your Claude desktop. Yep. And yeah, you just start the Claude once that is done. Yep. So we're just running a sample query, checking what all AWS accounts have we connected to. And just quickly just runs the given tool and just figures out all the AWS accounts that you're connected to right now. Yep. Yeah. And you guys can actually utilize this. And you can utilize this. You can scan this given QR code. You can open up the presentation on your devices, and you can utilize all the steps that is actually present. You can just simply utilize it. So yeah, I mean, all the presentation slides, all the steps that we actually just did on the video, these are the steps that we are actually doing. You can utilize this presentation to utilize it. Just copy paste the Athena bucket result, S3 bucket. This is the one that we are utilizing. I'm sorry. Yeah, it has access to the entire presentation. You can just go ahead. Yeah. So yeah. And once the config and everything is running, we can just start the MCP server with this simple command: run AWS Security SSH, AWS Security, SSC. We run like a normal server locally. And post that, we can set up our MCP client. So before we start into the labs, please ensure that you have like a Claude Code, Claude Pro Max version because of the token size and context window. You can utilize all the given commands on this slide to configure it wherever you want to. I would recommend utilizing Claude Desktop. It's better that way. And if you want to do a little bit more fiddling around, you can actually configure it on your Claude code and then create agents on top of it. So essentially targeting certain set of things, right? Yeah. Yep. Yeah. So you can actually extend, you can actually create agents using this. So whatever prompts that we are going to use for all the tasks that we have, and if everyone has set up their entire AWS config, SSO and all those things, whatever prompts and the tasks that we're performing, we can create smaller AI agents within Claude Code and then try to solve that. It's pretty cool that way. Yeah. If the setup is kind of done, you guys are following on the lab, you can actually, if you have any problems, you can actually refer to the troubleshoot. And if you still have problems setting up locally, you can utilize the given load balancer. I'm running an MCP server on my ECS servers right now, and you can utilize this MCP server locally, remotely, and perform the same operations that you want to do. Yeah, all the troubleshoot issues that we currently have. All right. So if all the Bedrock, AWS Bedrock, I haven't utilized it, to be honest. I haven't checked that. I'll go back to it.
A lot of AWS, I don't want everybody in the organization to do this. There's no reason to integrate it out the version of the scratch without production service.
Yeah.
Yeah. You know, but also.
How does this feel secure? How do I know which users they
Hmm. Yeah. So at this point of time, I'm actively building an authentication wrapper around this, so that actually people who are actually configuring to the SSO, that's the way that we actually figure it out. That's the first version of the MCP server at the moment. So at the moment, we don't have anything around authentication. That's pretty cool. Okay. All right. So if you guys are done with the setup and everything, this is the first section that we are actually doing. So you're a security on call for the week, and you received a bug bounty report from a bug bounty hunter saying that your attack surface is really interesting and that I can overtake your domains. So the product security team has tagged you on the Jira ticket, saying that a potential subdomain takeover vulnerability, right? And this is the entire storyline for this section. So the first and the foremost task is that we have been tagged on a ticket saying that the bug bounty hunter has reported a domain takeover vulnerability. We are treating it as a P2 ticket, and you need to verify any potential subdomain takeovers, and you need to verify whether or not there are domains that are vulnerable to elastic IP takeovers across my AWS environment. And this is a task, right? Can you share a list of AWS accounts, the public hosted parent public hosted zone, and the subdomains that are vulnerable to elastic IP takeover, right? And yeah, I mean, this is a task for you. So if you guys are following on the lab, you can just utilize the given task and start spinning up your MCP clients. And if you guys are not following it at the moment, I've added prompts, I've added videos on how you can solve it. So if you want to see, we can actually utilize the given prompt. So essentially, the prompt that we're utilizing is this, and the rules that we're utilizing is this. And then what basically it ends up doing is, I'll just showcase the video for the time. So the essentially the entire task was completed in 4 minutes, 20 seconds, somewhere around that. But so we're just running the given prompt and trying to figure out the task that we have on the workshop. Yep. As you can see, it's now performing Route 53 security operations, trying to figure out the parent public hosted zone. So it has found like one hosted zone in the current account, which is the place where we are running the MCP server. And then it has figured out the parent hosted zone for the given domain on the production account. Yep. And now it's performing those tasks that we want to identify the elastic IP takeovers. So it's performing all those EC2 security operations and investigating those IP addresses for the same.
Can you do something like what are steps you are doing, right? Identifying elastic, we kind of run that on a regular basis instead of.
Yes, you can do it. Yeah. I mean, like the prompt that I've shared is basically to solve this particular
Solve
task,
that
but you can actually
Try to-
utilize and break it down into smaller components as well.
Okay.
Like for example, if you want to specifically target Route 53 and scan for vulnerabilities around it, then you can utilize it that way as well. The task that I've designed it is basically on around the way that there's an actual incident that has happened in my organization.
Okay.
So
No, I was
majorly-
wondering like this is fine, like
Yeah.
it's but if I keep on doing it daily,
Yeah.
I'll keep finding the vulnerable potential subdomain takers right on a daily
Hmm.
basis.
on daily basis, it depends if your company is actually deploying multiple
Yeah,
domains.
yeah, obviously.
Yeah.
Like say my
100%, yes. Yeah. It's actually not it will not run like a cron job. You would have to write it down
Yeah,
and
yeah,
then
yeah.
something like that.
Uh-huh.
Probably you can do it with agents as well. With agents that can actually perform that task. Yeah. All right. So it has started investigating. It's investigating everything. And you can see the session context. It's deep diving into dev account. And it has figured out all the details. These are the accounts that we have. The parent hosted zone and the child hosted zone. And then there are domains that are vulnerable to elastic IP takeovers. Yep. If you guys have actually dealt with dealing elastic IP takeovers, it's pretty difficult. Sometimes if you have multiple AWS accounts, especially if you have multiple child hosted zones across your AWS accounts. All right. And yeah, so you can actually take the response, add it onto your Google Doc. I've added as a Google Doc here so that you can refer to it. And yeah, we got the outcome within like 4 minutes, 20 seconds. Given the size of the account is actually small, but ideally the responses would be very, very straightforward and pretty easy. So if everyone is kind of done with this particular lab, we can kind of move ahead to the second one. So which is basically around the same storyline. again, we are dealing with Sec 1001, where we are tagged as a security on call. And now that we have shared that response back to the team, product security team, now the team actually has trying to solve for elastic IP takeovers and have added SRE on call. And the SRE on call says that the external attack surface of our infrastructure is a little confusing. The kind of findings that we have on IAM Access Analyzer are somewhere around 20,000 alerts. So to prioritize that and understand what exactly is important and not. So that is what we're trying to solve here. So the SRE on call says that the number of alerts on the dashboard are quite overwhelming and are having tough time to prioritize the findings and figure out a legitimate attack hypothesis, right?
Great job. Thank you.
Thank you. So what we are tasked to do is that we have to create a detailed report on all the findings from IAM Access Analyzer, the external IAM Access Analyzer. And the report should contain all the given sections. One is executive summary, and then a potential attack vectors from all the security findings that we have on the IAM Access Analyzer. And then the section of action items where we are trying to prioritize all the action items again, right? So yeah, this is the task for this. And if you can utilize the given task and just copy paste it, it will actually do the same thing. But for the sanity purposes, we can utilize this prompt where it actually breaks down this task into smaller chunks and then tries to create that particular report that contains executive summary and attack path analysis. And we're also adding a lot of rules so that it actually does what we want to do. And then yeah, this is the output that we're expecting. The report should be somewhere around 500 to 800 words. And yeah, the section is and like a report which is like a reprioritize security findings essentially. So if you want to and check the video, this is the way you can solve this entire lab. So again, the same prompt I've just added, pretty straightforward. All right. Yep. So if you can see, like the MCP server, MCP client is now analyzing all the AWS accounts that we have, checking all the access analyzers, trying to actually reason with it. And then it's figured out multiple findings from different accounts. Yep. And now it's utilizing sequential thinking to actually plan out its strategies. Yep. This is the output of the report. So has found around 3 public S3 buckets, 2 messaging queues, 6 external trust relationships from different type of resources. It has also figured out a supply chain attack vector as well. And it has given all the action items that we want to prioritize accordingly. Yep, that's about this task. All right. So if you're following with this, this is the output of the report. You can refer to the given Google Doc and check how the report actually generates. That let's move to the second task, which is the again similar storyline, but now we are doing the same thing on SecurityHub and trying to perform the similar actions. So again, right, I mean, you can utilize the given prompt and actually utilize the report that we generated and then actually ask it to refer across, right? So that's the way that we can do. And then generate the similar report at the same time, right? So again, if you kind of go back to the video. Yep. So it has figured out all the security of findings, and now it's trying to investigate all the resources that were vulnerable and all the findings and the resources that were actually added in the security hub. Yeah, is the finding reports. As you can see, the security hub has like pretty detailed findings most of the time, and it has started figuring out the attack chain and technical analysis of different type of attacks that are possible within my AWS account, with utilizing the findings that we've got from the security hub. And this is the final report. All right, so we are done with this video. Let's just quickly. So I think we are done with this section. You can refer to the outcome report again as a Google Doc, and you can see how the report has been generated using the MCP server. And then the entire section has been wrapped up. The reason that I'm trying to keep it as a little faster pace is because the entire goal was to showcase how we can utilize this MCP server and perform operations in a quicker manner, right? So with that being said, what are the learnings from this particular section? So we learned how to set up the MCP server locally. We learned how to identify elastic IP takeovers. We also learned how to prioritize security findings from different AWS security services. We also mapped out our critical attack surface. We also did like a little bit of a correlation from different findings from SecurityHub. And then we also did like a lot of connecting dots and actually made the most out of our findings, like 20,000 alerts or something like that, right? So with that being said, that was a wrap up of the first section. Moving to the second section, this is an interesting one where our threat detection team has reached out on a common Slack channel, querying about a suspicious load balancer, public load balancer, created on a stage account by a dev named Harry Potter. The detection team is treating this as a P1 security ticket. And as a security on call, the threat detection team has tagged you on a specific ticket, which is Sec 1002. And the title is Public Load Balancer. And the task is pretty straightforward for this. We need to figure out what are the resources owned by all the resources owned by QA team. And we have started the quarantine process, right? That is what detection team has actually added as a comment on the ticket. So what our task is, we need to gather all the resources that are owned by QA team. And the tip is like our company follows strict tagging policy. So essentially utilizing the prompt again, if you've been following, you can utilize this given prompt and get the valid results like all the resources owned by our QA team and actually generate valid responses and Jira tickets for this. Yep. Yep. And as you can see, the MCP server was able to identify around 9 tagged resources by the team QA team. And yeah.
Because we don't know what really is telling that there is some reality on the outcome. Because it's a server and we really want to know outside.
That's the first part of the section. And yeah, I think this is pretty straightforward, very fast. I was able to identify the resources that are owned by a specific team. You can also, if you have a pretty strict tagging policy, if you're a PCI environment and all, even the resource owners, you can try to find. Let's say if you want to find some like resources owned by a dev named Harry Potter, you can just add like owner and Harry Potter and just get all the results with it. So yeah, I mean, that was the first thing and first part of the section. And now the ticket has been raised to from P1 to P0, saying that the we received a GuardDuty alert and the given ID for that GuardDuty alert, and we have raised it to Dumbledore's office. And Now we are asked to actually perform a security review threat modeling of all the resources owned by this team. And we need to share all the possible attack kill chain from these resources. And the detection team has started the investigation parallelly as well. And then we are tasked to create a threat modeling report for all the resources. So this is the alert that we got from the GuardDuty, and you're tasked to perform like straightforward threat modeling and security review of all the resources owned by the team. So if you see deep dive into the prompt, it basically says around that we want to target the GuardDuty finding, and the cloud security team is going to perform practical attack kill chain report analysis on this, and we're going to deep dive utilizing this. So essentially, if you just copy paste this prompt and check the output of this. So we're just following on the previous task and just adding.
Someone in her or whatever, but when we made it the time, that were making the target and things like that, so the word is right.
So for the task, we are just performing a security review threat modeling of all the resources. And for the given prompt, it has already started performing all the operations that it needs to perform. So all the resources owned by the QA team, like load balancers, Lambda functions, EC2 instances, SQS queues and topics and SNS topics, everything. It's deep diving into every single resource and trying to understand what can go wrong. That's what we're trying to perform. Yeah, as you can see, we have a internet-facing load balancer for this team. There's EC2 instance configurations, right? An IAM instance profile, a key pair, SSH key pair as well. And then you can see we have a Lambda function which exposes like a AWS IAM access key and secret key, which is again like a severe critical issue. Yeah. And you can see that is the timeline and resource ownership and everything. Like basically got the entire results and whatever you wanted to perform for this particular operation, right? Yep. So now that we've figured out what are the resources owned by the QA team, we have deeper into the GuardDuty finding, and we've also understood that okay, these are the possible attack kill chain possible from all the resources that we have. Now we have actually developed this report and shared it with the detection team. And the output report, as in, I mean, you can refer to this report, but it's a very detailed report, different type of attack chains and kill chains available for this, right? And now moving to the third section, which is around more deeper into performing log analysis, performing log correlation and all those things. So the detection team has kind of impressed with our reports, and they have invited us to actually work alongside them to investigate an ongoing incident, a similar incident. And they have granted you access to all the logs and Athena security operations as well. So with that being said, let's just begin with the first task of this. And the first task is pretty straightforward. They're asking us to create a chronological timeline report of timeline overview of this incident that happened, where we are saying that the Athena database is this one, table is this one, this is the IOC, and this is the date of the event that happened. And please share their findings and all those things, right? So essentially, we are trying to create the timeline of the incident. We're trying to understand what this attacker did on my AWS API layer. And if you kind of go ahead with the prompt, it's pretty straightforward, but the rules are pretty defined as you can see. It basically says that we need to perform second order investigations if the attacker was able to invoke or like basically create something or delete something. We need to check if these resources are actually messed up or not. So that is what we are trying to do. We have also given like a CloudTrail Athena configuration as well and a sample query so that the LLM understands what to write and how to write it, right? Similarly, if we kind of deep dive into the video and the solution of this. Yep. So it's actually now strategizing the entire operations. And the output is basically like an RCA report for CloudTrail data specifically. So now you can see we are utilizing Athena security operations and we're trying to search for that IOC within our CloudTrail logs. So it's again running like a validation query. If you're dealt with CLI and SDKs around Athena or like pagination results on Athena or any other AWS service, we usually get a next token in the response back as a JSON. So we have added as a rule as well that you need to check the next token as well so that we get an entire value of the logs and create a detailed reports. And that is where your hypothesis around, whether or not is actually valid or not. That is where we're trying to add the more data, give more data to the LLM. Yep. All right. So we have actually fetched all the results. We have utilized sequential thinking. We have started developing our report specifically for this. And this is a timeline report that the MCP server client is able to generate. So as you can see, the attacker had advanced knowledge of AWS services, employed social engineering tactics through legitimate looking resources, right? So the attacker actually came in and created an EC2 instance named as Stage Jenkins Deployer, which is wants to cover its tracks and all those things so that it looks legitimate. And you can see the detailed attack timelines. The phase one was basically access denied. The attacker had compromised a specific EC2 instance and tried performing multiple API calls to check whether or not there is a privilege escalation path. Figured out that there's an AWS Lambda access allowed. From that AWS Lambda, it fetched the environment credentials and then pivoted from that point onwards. And then created a new EC2 instance because that IAM user key and access secret key had access to EC2 described EC2 full access. And phase 4 continued operations, ongoing movement, potential lateral movement as well. And yeah, I mean, that's the place, right? I mean, that's what I was trying to say. If we wanted to create these hypotheses and we wanted to actually validate these hypotheses and create these assumptions as well, we would have to spend a lot of time, probably hours or probably days as well, if you're dealing with situations like these, right? Teams that have very, very defined security programs, defined security teams, for them, it's not such a big deal. But for companies that have like a very, very small security team size, for them, it's such a big pain in the ass to figure out what exactly went wrong, right? So you can see the user switched back to this particular instance and then switch forward to privilege. Okay, so basically the attacker actually escalated its privileges to the specific another user and then tried creating an EC2 instance. And it did not even stay at one single identity for such a long time because then it gets detected. And then, yeah. So it has basically it was able to figure out the entire uh, the entire footsteps of that attacker across my AWS infrastructure. And that's how you can actually deal with CloudTrail data with this MCP server, right? All right. So if you guys had fun with this, so the entire report, you can actually refer to this. It's a very, very detailed report. But I would recommend that you guys kind of go through it because the kind of data that it was able to identify, like for example, doing role assumptions and then pivoting from Lambda to creating an EC2 instance, all those attack paths, it was able to identify and reason with it pretty well. So that's pretty cool. All right. So this is the last task. And again, it's something similar. Uh, we are trying to deal with VPC flow logs this time. And people who have dealt with VPC flow logs, you would understand how big the size of this logs is. Sometimes when you're ingesting it on Elastic as well, if you're running a self-hosted Elastic, you might end up breaking the entire stack as well. But in this use case, we are utilizing Athena perfectly. So yeah, I mean, we are dealing with VPC flow logs, and it might be possible that the VPC flow logs are like a terabyte per day kind of a log source. So again, so we are just deep diving into the VPC flow logs, trying to identify the IOC and trying to see what exactly went, what did this attacker do when this user actually created an EC2 instance after the compromise, right? So I'll just showcase the prompt, but essentially it's a similar one and similar one that we utilize for the CloudTrail. And you can utilize a similar prompt to actually start investigating the same one. It essentially has the entire data like VPC flow logs, partitions, the database name, the full path, etc., etc. And yeah, we'll just go through the video. So if you can see, the MCP client has started validating the queries and started running the similar operations that we were running for CloudTrail. All right. So it has successfully figured out that the IOC was actually running multiple networking events from this instance. And it's also performing a second order investigation where the EC2 instance that the attacker created, it's also validating what are the what kind of network traffic was generated from this particular EC2 instance and trying to see what all private IP addresses was it able to actually interact with. Yeah. As you can see, like the strategy worked well. It tried probing port 80, that did like a lot of network scanning, all those kind of events. All right. So the IP address that it figured out, now it's actually figuring out what this IP address belongs to. So it has identified that this IP address belongs to a load balancer. So it's actually deep diving into that load balancer and checking whether or not it's the configurations are fine or not. And it can say that it does say that the attacker accessed the load balancer as well. So the dots that are coming, like the IOC, essentially the one that actually started this entire compromise, is actually coming from like created an EC2 instance, and then from that EC2 instance, it started the entire network scanning and all those things. And yeah, and it's performing a second order investigation now for the same. Yep. So if you can see the executive summary and the entire report has been generated, the entire timeline of the incident has been generated. And it can see like the attacker initiated an ICMP probing from this IP address. And then heavy bidirectional SSH connections, like basically saying that there were multiple SSH connections by the attacker. And the attacker actually created this and started network scanning and all those things. It targeted multiple subnets, sent a lot of TCP SYN packets as well, around 60 bytes each. And then again, it kind of queried ECS containers as well, tried scanning ECS containers for ports and all those things. And yeah. And as you can see, the attacker actually created 3 different EC2 instances with the same name, which looks like a CI/CD kind of a instance, or like Jenkins or something like that. And yeah, the data exfiltration as well happened. At the moment, it says 151 KB, but ideally the traffic was pretty big. Yeah. And if you kind of refer to the report once again, it's very detailed, the different type of paths that this attacker did and different type of things that it performed during its entire incident. And yeah, this is the incident report for this entire investigation that we were going through. And yeah, and let's just discuss the timeline. So the attacker actually started at 10:30 a.m. Started with an SSRF exploitation of an QA EC2 instance. The attacker obtained the EC2 IMDS credentials via the SSRF, which led to rapid Lambda enumeration. And post that, the attacker discovered that this QA data sync function is actually vulnerable. It has IAM credentials added on the environment variables. The second step was escalation part, where the attacker started from 10:31 a.m. to 10:34 a.m., which essentially said that the hard-coded access keys on that Lambda environment variables, the user actually switched from that and then utilized those IAM credentials and then started maintaining persistence around it. So from 10:36 a.m. to 10:37 a.m., within 1 minute, the persistence was actually done. Like the harvested credentials were utilized to create multiple EC2 instances. And then it was utilized to create public security groups as well. And then the exfiltration happened later in the evening, somewhere around 5:30 in the evening, 5:30 p.m., where like the Nmap scan and the network scanning started eventually, right? So essentially, what does it mean? If you can see the timelines, the attack actually happened for just 1 minute, or probably like 5 minutes or 2 minutes, right? But the logs that we generated, the attacker generated, all those reasoning and all those dots that we wanted to connect while actually checking or actually investigating the timeline of the report of the incident, the LLM was able to actually identify and perform all those operations equally. And that is where the MCP server actually helps you guys pretty well, right? You can actually do a lot of correlation, a lot of connecting the dots and all those kind of things with this MCP server. So what are our learnings from this entire section? How to solve complex security tasks. In the first section, we were trying to solve little basic type of tasks, right? Trying to identify the connected accounts, elastic IP takeovers, etc. But in this one, we tried to deep dive into the logs, did a lot of log correlations, and then tried to identify the resources owned by this team. We also formulated practical attack kill chain across the AWS infrastructure. And then we also did like identify the attacker's entry points, different type of places the attacker came from. And then we also identified the attacker's activity as well, right? The attacker's activity, whatever operations that the attacker was performing during the incident, we identified that. And then we correlated multiple log sources like CloudTrail, VPC flow logs, and all those things from like for basically getting the sanity for all the events that was happening. And then we generated a practical investigation report and not an hypothesis, right? We generated a valid RCA, which can be shared with the team and can be dealt with on how to deal with this particular incident. So let's try to understand the state of the cloud security of our organization. So the first incident that happened, that was the SEC 1001, the product security team alert that we got, plus the one that we actually just generated one for the SEC 1002, the detection one. We just combine the reports and just create a state of cloud security of this AWS organization. and then figure out what is actually wrong and what can be actually prioritized in my AWS account at the moment, right? So if you kind of deep dive, you will see, different type of problems that the current company has, the vulnerabilities that is actually present within this organization and all those things. So that is all, guys. That is the workshop. What are the key takeaways? So the entire operations that we did, other than AWS configure SSO, we had 0 CLI tool invocations. We did not even open one single browser tab. We did not even go ahead and did like a fiddling between logs and LLMs, right? The table schema that I was initially talking about. And then we made the most out of our security findings in just 40 minutes, right? That's all. So yeah, that's a wrap. I'm open for Q&A. You can connect with me on LinkedIn and X. And special thanks to Cloud Village team, DevCon team, and workshop participants. Thank you. Okay.
So, Saransh,
Yeah.
Your experiment was how you can expedite your analysis
Yes.
and investigations
Mhm.
or business operations like
Threat modeling, security reviews,
tagging
assessment.
of
Yeah,
really cool exercise.
Thank you.
What I do want to ask is, so you use Claude, did you think of something else as an asset backup? Did you think about using other models? Because if you use something that's native to AWS,
Mhm.
I would assume maybe it could be like there's a richer or
Makes
maybe
sense.
faster finds.
Makes sense.
I know that you're kind of piecemealing. It
Yeah.
still works great.
Yeah.
I'm just saying something that's more baked in.
Yeah. So for the given timeline and the workshop, I did not really test Bedrock, but yes, 100% you can do it. I've tested it with Claude Code, Cursor, and Klein as well. It works pretty well. But yeah, Bedrock is going to be on my priority list now. Second is the authentication part, which the member actually mentioned. Yeah. So yeah.
The XP server that you said, can it be used by the threat hunting teams too?
100%. I mean, most of the log sources that we were dealing with, threat hunting team deals with that same, right? And I'm going to grant access to the lab for 72 hours. So you can actually deep dive into the entire lab once more. I'll just open the QR code for the lab once. Just give me a moment. So that you can just scan it quickly and not this one. Yeah, you can actually scan this QR code. You'll get access to the presentation and you can just deep dive into the presentation as you want and send it across your teams. The AWS account that I've created is essentially a intended vulnerable account. It's more or less like a CTF. You will have fun doing things around. The date of the incident is 25th July. So you can just refer to the presentation. Yeah.
Okay, that's a wrap for us on this side. Thank you, Saransh, for traveling 8,000 miles to deliver this lab.
Thank you.
Thank you. We learned about the conversational AWS security. The session is packed with the websites, and you also had those videos.
Yeah.
So it will make up a really, it was a very valuable session.
Thank you. Thank you.
Thank you so very much. Can we get a big round of applause for it?
Thank you.
I like the format of the presentation.
Thank you.
Very nice, very flow.
Thanks.
I like the